Welcome to another RDWorks Learning Lab. Today I'm going to break two promises. The first promise is I wouldn't make this machine the star of the show. I'm going to bend that promise a little bit today, but it's to your advantage. The second promise was that I was not ever going to make another Mk6 of the laser pointer. I think we got up to Mark 5 and I said that's enough. No more laser pointers. I've gone as far as I can. Well, that's the second promise that I'm breaking because I've now got a Mk6. And why have I got a Mk6? Well, basically it's an adaptation of the Mark 5 to suit the requirements of this machine. Now this machine will be similar to many of your machines, especially if you've got a red sail clone type machine. The mirror configuration is completely different to my mirror configuration, and the space available to put the laser pointer is substantially less. So I've had to completely rework the design and produce some kit that will enable me to test this machine as opposed to my machine. But of course I've used a lot of the basic ideas that I've learned and developed on my machine over there to apply to this machine because I still feel so comfortable with the techniques and I know that they work. So what we're going to do today, and why it's such a relaxed session for me, is I'm going to re-crunch some of the video that I've already produced for Think Laser, but don't tell Think Laser. I'm going to re-crunch that video to show you some of the tools that I've made and make them available to you as well. Because I see no reason why you can't have these pieces that I've got here in front of me. Let's start off with the laser pointer. I mean, this is an adaptation of the Mark 5 laser pointer. Yeah, I'm quite pleased with the way it's come out. It works very well. And we shall see that demonstrated in the video. Although I haven't used it in anger yet, we've been using these devices as a training mechanism for learning some of the tools and features of RDWorks. And here we've got some targets and target holders which will fit onto your mirrors. And here we have an alternative hands-free version of what I affectionately call the Laser World's anal thermometer. Okay, well the time has come to start doing something with these pieces. Now the thing that we've got to do with these is to assemble them, and we've actually got to glue them together. When I say glue them together, we shall need a special adhesive for bonding acrylic. Now I've got a material here from a company called Bondrite, and it is actually a PETG weld cement. Now technically I should have acrylic weld cement, but I know that PETG weld cement will do the job. Acrylic cement won't weld PETG, but it will work the other way round for some strange chemical reason. Now this stuff will evaporate very, very quickly, so you need to make sure that you always keep the lid on. They normally give you a little bottle, and what I do is I'll just squeeze the bottle and very slowly release it so that I suck some of the fluid, which is just like water. I think you can probably see I've only got a very small amount in the bottom there. So we pop the needle on the top there like that, and now we're ready to begin the assembly. So there's 4 pieces to this one and 4 pieces to that one. Now it is actually pretty obvious how these go together. So it's as simple as that. But now what we've got to do is to bond it together. And the way that we do that is we will try and keep our fingers away from the actual little tenon joint, and we shall lay this in a horizontal plane, and then I don't know whether we can get close enough to see it, but when I tip this up very gently, the fluid that's in here, which is very watery, will just flow out, and it will actually, by a capillary action, flow into the joint. There it is. That's as simple as that. It produces a really neat little joint. Now I've got to hold that for something like about 10 seconds, 15 seconds, just to get it to bond and dry off. And again, I'm going to run this very gently, just turn it off of horizontal, and then when it runs, just go straight along the joint. Now after about 15 or 20 seconds, that will have fixed, and then I can run along this joint as well. There and there. Now, I don't know whether you can see it in this light, but here's the marks that I was talking about along the back edge there on the edge. Those marks haven't affected the surface of the material, but they have actually just impacted along the edge there. That's the reflections off of the honeycomb section. It's not a major issue, it's just interesting that I can see them. Well, there's our first target holder made, and we'll pop our target on there. The target locates here, and so it's repeatedly sitting in the same position so that we can fire a laser beam at it. But I'm afraid you're going to have to be patient to see that, because we've got a few more sessions before we get to doing anything with this. This next item is an interesting item as well. Now, I've put these two pieces together like this, and I've produced basically what looks like a pocket here. Now, you would normally make that out of one thick piece of material, and you would mill a pocket in it, or you could make this out of a piece of 6mm, say, acrylic or 5mm acrylic, and you could try engraving a sort of a pocket in there, but it wouldn't be all that accurate. This is a much more accurate way of making that pocket with two pieces. But then you have the problem of, how do I stick it together? Well, we have got this stuff, remember, but I'm not going to be using that for main location. What we're using these pieces. Now, these pieces, if you look carefully, we've got tongues on the end which are twice the thickness of the material. So I'm going to pop those through those slots. It all locates and locks together nicely. Run along this edge here like that, and then I can run along this edge here like this, as quickly as that. And to be honest, it's nicely held together. If I can manipulate my hand over far enough, which looks as though I might be able to, I could probably run along that one as well, which will save me waiting too many seconds. Now, the only other thing that we've got to do is this piece here is a little bit on the flimsy side. So what I'm going to do, I'm going to run a bead of glue along that joint there. Well, that's the end of our first programming and our production project. Now, these items will be used at a future date, and we've got a couple more that we're going to manufacture that will be used in conjunction with these during one long session for checking the performance of the machine, so that we've benchmarked the machine. All our pieces now with the film stripped off. We're going to need an assortment of parts, which I will describe as we go along, but there will also be a listing of this. Now, the one thing that won't be defined is this. Now, I defy anybody to say they haven't got at least half a dozen of these click pens around in their drawer that either don't work or that they don't need. Well, now you've got a use for them, because inside here is a valuable resource. And there it is. We shall need 2 of those springs. If you can find a matching pair, brilliant. If they don't match, don't get too upset. Okay, now the first item we're going to pick up is this one with all the big holes in the middle. And if you look carefully, you'll see that around about 10 o'clock here, we've got a little hole, 3mm hole. Now, we need to pick up this piece as well. And again, you'll find that you cannot put this one on and match the holes up unless you put it on the right way. So that sits in front of there, like that. And then you can turn them over, one of those and then 2 of these. Okay, now at the moment I've got my hole down here at about 5 o'clock or 6 o'clock. Slide this piece off for a moment, and we're going to put the one with the hexagon on in front of the one with the hole in. And then we're going to put those tongues into that hole there, so that the hexagon is facing this centre hole. And then we're going to take this piece and we're going to drop it over there, like that. And that should sit in there, and that should all lock in there nicely now, like a little corner reference angle. Now we're going to do exactly the opposite over this corner here. This little piece here will drop over and cross-lap with that one and plug into that. Match up the hole in here with the hole in here, and we're going to slip this one over the top. And technically it doesn't need gluing at all, because everything is nice and snug in there, but I would advise you to glue it. We're going to use this Bondrite cement again, which technically, as I keep telling you, should be acrylic cement, but this is PETG weld cement, which will perform satisfactorily on acrylic. A few drops in the bottom of that bottle, that's enough to do the job. Now I would suggest whenever you're using this stuff, you do it over or on a piece of kitchen towel, because it is quite aggressive to surfaces, and also you don't really want it running anywhere. So it does, if there's any excess goes through to the other side, it will automatically soak up in here. Now the light may or may not be right for you to see this, but when I pop that in there and tip it up, I should be able to get a little bead to run down there, and I'll get a little bead to run down there as well, and one down here, and one down here. Now I can feel that it's already run through the back onto my fingers, so I'll just wipe the back off. The next piece involves these little llamas. They look like llamas or reindeers. And if you look carefully, you'll see that 3 of them have got noses, and 1 of them doesn't. So the one that doesn't have a nose on it, pop it to a side for a minute. Now if you can read that text, then round about here at about 8 o'clock time, you'll see there's a small hole. There should be a matching hole in the disc, so you should be able to line them up. But the reason why I'm asking you to do this is because these have got to go on the back of this. So we turn it over, and one of those with the nose on, we're going to have to very carefully try and get it through both thicknesses. Now that could be quite stiff. We're not relying on anything other than friction to hold this together. So if it's not a snug fit, then realistically we've got to go back and we've got to remake these holes here to make this a snug fit. Now that's a completely different design exercise which I need to go through with you at some future date, how you're going to design parts to fit, because it depends on the lens that you're using and various other things about the material that you're using, the fit that you're going to get. Now what we need is this little thing here. Now this is only a few pence off of eBay, and it is in fact a laser diode. So put your cable through the hole to start with, and then very gently, because these cables here are delicate, that should sit snugly between the reindeers. The nose of the reindeer should fit in a slot that's round here, and that will lock that in place. So this needs to be pushed in. Make sure you've got the noses of all of the reindeers pushed in. Then we need the reindeer or the llama without the nose on as the last one. Now before you put that one in, if you take a look, you'll see there's a little circuit board on there. Make sure that that circuit board is not projecting anywhere to get in the way of the llamas. That should be sitting between, somewhere between the llamas. If these little pegs are sufficiently snug in these holes, this should be completely solid in here and not rock around at all. Now if you really need to, you can glue the bottom there, and you could even put a blob of glue down against the laser diode as well. The point is the diode must not move. It's got to be rock solid. Now in normal engineering circumstances, I would suggest you drill where we'd put the hole through there, and I would physically be tapping, putting a tap through there. but understanding that probably most of you guys might not have tapping facilities, what I've done, I've arranged to put a nut in there instead for a tapped hole. Okay, so we put a nut in there and we put one of these long 1-inch plastic screws through there, but make sure that it doesn't stick out above this surface. With the 2 screws at the top and the light blade description sitting the right way round, you will see that this little piece at the back here, if you look carefully, you'll see that it's radiused, it's curved, and it sits in these little slots here. And if you rock it around, you'll find that it rocks around very easily in 2 planes. Now, the idea of that mechanism is that the front face of the LED always remains in the same position in space. It's the back end of the LED which is swinging around, not the front end. Now the next part of the assembly, I need you to make sure they go together like this with the holes lining up with each other. And before you start using these springs, which we've cut down, so they're probably about 15 mil long, the springs, but then I want you to get hold of the end of the spring where you've cut it and physically just bend it out. Like that. Can you see that? So that it sticks out about 3 millimeters. Now the reason you're doing that is because the spring will actually fit down and jam inside the hole, and we don't want that to happen. At 3 o'clock we're going to put an M3 screw through, and then we're going to put the spring on with its tail against the plastic, and then you're going to put the nut on. As you can see, the spring is about the same length as the screw itself. So that's an ideal guide as to how long the spring has got to be cut down to. And then we need to wind the nut on so that it's just flush with the screw. The one that's at 6 o'clock we need to do the same thing with. Okay, now if you grab hold of these 2 holes opposite the springs, you should find the whole thing will flex up and down, and you've got a nice little sort of bouncy compression flexi system. There's your other 2 M4 nuts, and put those behind there. There is a cavity behind there to take the nut. Hold it in the cavity and put your screw through from the front. Okay, so hopefully we've now got a nicely little gimbaled LED pointer. Now I'm just going to go with my soldering iron and attach some extension leads to these. Here we've got a cheap battery box with a couple of AA batteries in it with a switch on it. So it's a nice convenient portable tool. You could buy these as a 5-volt diode, and you could probably hook it up to your USB system somewhere, but I thought that the 3-volt version would work better with a battery box. Well, here I am at about 1.5 meters away from the wall where I'm projecting this onto, and I've got a spot there that is about probably 4 millimeters diameter. As I close in to what, 6 inches, it might have dropped to 3 millimeters. It's not changing significantly. The flare pattern or the interference pattern around the outside is changing, but the actual dot itself is not changing. Let's see where it goes and what we're going to be able to do with it. Right here, so we're going to be able to drop that in there like that. Make sure our nuts are pulled back into the slots. There we go. That should be flat back on the front face of the water jacket. Now we can turn it on. And you may remember in one of our earlier sessions now that we made this as our first project. And this is a little target holder. If we open up the side door of the machine, our little target holder sits on top of that mirror plate there. Make sure it sits tight against the plate at the bottom so that it's sitting back nice and flat. There's the beam lined up on centre one way, and now I'm adjusting the screws to line it up on centre the other way. Now move that one out the way, or we can leave that in place and just remove the target, because the beam is designed to pass through there, so we could leave that in place like that. And here we have the other target holder that you made, and that fits snugly over this mirror number 3, fits snugly back against it, and we can hook the target in the top there, and we can see how we're lined up on that one. So that immediately tells me that there's some sort of problem with the alignment of the mirrors on this machine, which I'm going to have to look at sooner rather than later. So maybe that will be the next session now that we've got this tool. I could tweak that up to come into the right place, because the fact that I've set it correct on mirror number 2, so that's now more or less correct at mirror number 3 at the extremity of the beam path. Let's just go back and check what it is at mirror number 2. Well, that's what mirror number 2 looks like. It's a bit high, but it's still hitting the mirror because it's still within one target ring. And we'll talk about what those rings mean in the next session. Thank you very much for your time again. I hope this has been an interesting one. I think it's going to be even more interesting in the next session, actually. That's cut quite cleanly. There's that watery substance that I was telling you about. The sticky substance that gets produced when you cut. Yeah, it's all on the back here as well, which is good that it's settled on the back of the product, because it means it's not settling in the filter system. This honeycomb bed has one great advantage for cutting card and paper, if you're not worried about marks on the back, and that is in fact the airflow that's passing through here has got like a suction effect which flattens the paper out onto the table. The machine is moving around very nicely. It's quiet, it doesn't rattle and rock and roll. It's very smooth action. I think those cuts are still too thick. But that may well be because it's a 2-inch lens, and I'm always used to looking at a 1.5-inch lens line, which is very, very fine. Okay, now just for comparison, I've run the same program on my other machine with the 1.5-inch lens, and yeah, I know this has nothing to do with this particular job, but it's all part of the learning process. You can see that it's a much, much finer cut than we're currently getting with this particular lens. Now, I don't know whether this thick cut is because of the lens, which I know will have a different cut width, but I didn't think it would probably be quite as big a difference as this. But we shall find out when we do a little bit more investigation work further into the series. Now, because it's nice and convenient and light, I'm going to be using the machine as a workbench now. This is a little workshop. Now, these are the pieces that we've just cut, and I'm going to make them up into a very simple little assembly. We've got long pieces and we've got short pieces. We want the 4 long pieces to start with. We should find these with like 2 slots pointing up away from these tongues. Drop those into that square first, like that. Stand them up in the square. we shall find the other ones which have got slots along the bottom edge. And there we go. They will go together and make a little square assembly like that. And now that we've got them together, we're going to have to use some of our cement. We're going to just run the bead of cement along the bottom of each edge. And what we will do is turn it upside down, and we'll just apply pressure to the bottom of it for about half a minute. Okay, and having done that, we can put that aside. Now, the one that we want to work on is the one with the curved slots in it, and you'll find that there's two with slots that stick up in the air. So the ones with slots up go on opposite sides first, and then you'll find there the other remaining pair have got slots pointing downwards, and they cross-lap into there like that to make another little box assembly. And we've got to do the same with that one. We're going to have to put some glue along the edges, and again we'll try and turn that over, and we'll hold that upside down for another 30 seconds or so. We're missing one vital part. So I'm sure that somewhere around your premises you will have, I'm sure you'll have some elastic bands. Now, they don't need to be very big elastic bands, but I don't know what size I want. So I'm going to try the small ones to start with. They may or may not work. Oh yes, they will work. And look, we're going to thread we're going to thread an elastic band through that way, and an elastic band through that way, and we've just made a little trampoline. Look, because we're going to now add to the trampoline one of these little targets that you made, and we pop the target in there like that, and this last piece sits on top of the target, like that. And I can hear you saying, what sort of worms are in that guy's brain? What the hell is that? I did promise you I'd tell you what all this was about when we got back to the machine, and I've now turned the machine on, and I'm just going to drop the table a little bit. Here I've got something which I've always affectionately called the Laser World's answer to an anal thermometer. The only way you can tell it's an anal thermometer as opposed to an oral thermometer is probably the taste. This particular little piece of kit is the same sort of thing that your mum used to use when you said, oh, I've got a headache, mum, I've got a stomach ache, mum, I can't go to school today. And the first thing she'd do is get the thermometer out, and she'd put it in your mouth, and very quickly she'd say, there's nothing wrong with you, off you go. Well, this is the same sort of technique that I'm going to be using here. It's a very quick and dirty way of checking whether or not the machine is in ill health. Now, the normal use for this is you'd put a piece of masking tape on the back like that, and then at each corner of the machine, the back corner and in the middle of the machine, and I would just pop this into the middle of the machine. It doesn't matter where it is at the moment, to be honest, but you'd pop that into the middle of the machine. You would set the pulse power, in other words the maximum power on the machine button, you'd set that to 15% so that it's fairly low power. The holes in here just neatly fit over and snuggle onto the end of the nozzle there, so that the hole centers on the nozzle, and then you can just do beep, which is a pulse, and there we go. Look, you get a beautiful hole. And if you put that around the machine in 5 positions, you would expect to get, I mean, I've got a pattern, a perfect pattern there, where all the holes are exactly the same, because obviously I've used it in the same position. But if you move it around the machine, those holes should be like that, all in the same position. If they're all out of position, it means your beam is totally incorrect. But the problem is, I can't ask you to do this, because I need the cover open to hold it under the nozzle. But this is such a powerful test that I have reinvented this device to something that you can use for yourself. And it's this little trampoline. And what we're going to do, we're going to raise the table now so that there's about maybe 1/8 of an inch overlap between this and the end of the nozzle. And what I can then do is, this is the central position, look, I can just pop that on there like that and it's held up against the nozzle. And now I can just go pulse. And if we look carefully at that, we can now see, it's not very central, is it? That's another interesting point. It's all over to one edge. That's what this piece of kit is, and we should be using that in the next session to find out just what the benchmarking data is for this machine. And we'll, if necessary, we'll give the machine a tune-up. So I think we're all now kitted out, ready to start. And the next session will be all about finding out just what we've got here. Okay, so you've caught me on my knees. No, I'm not praying at the altar of Thinklacer. I'm actually toying with the idea of how am I going to turn this lens system into a 1.5 inch lens, because the system that they use, and probably some of you guys as well, is a nozzle screws on the end here and the lens is actually buried up inside there. Now that makes it particularly difficult to get a 1.5 inch lens, because a 1.5 inch lens is actually going to sit somewhere up there inside the nozzle itself. So that's going to represent a little bit of a problem, but I think I've got several ideas of how I'm going to achieve that. They tell me that it's impossible and I can't do it, but that's the only thing that I need to make it happen. Somebody to tell me I can't do it. But that's not your problem, that's my problem. So I hope that's proved to be an interesting session for you. The only thing that I will say with all of these tools, you must remember that the drawings will be available to you. All you've got to do is give me a personal message and let me have your email and request which, if any, or all of these that you require. Now, you will have to modify this to suit the water jacket diameter of your particular tube, because this is for a 27 millimeter outside dimension water jacket, and so you'll have to move all of these dimensions out a little bit and play with the design for yourself. But in principle, it should work for everybody. Well, I don't think there's really a great deal more to say before we finish this session. It's been an easy session, as I said, because I've had little to do other than sweat over an editing suite, and I haven't really had much pleasure from this machine today. I said I was going to be faithful to my little Chinese lady over there, but yeah, this has got some sort of fatal attraction attached to it, and I do keep coming back and playing with it because it's smooth, it's clean, it's well engineered, I like this bit just here, this open front. It's really very nice to work with. I'm not working down in a hole. Everything is nice and easily accessible. Yeah, I'm falling in love with this machine quite a lot, but I'm detecting that there might be 1 or 2 small issues that I've got to deal with on this machine. I noticed that the beam is slightly out of line. Now, that doesn't mean to say it's wrong. It just means to say it's out of line and I don't like it. I like things to be spot on. And so I shall be working through this machine with a fine-tooth comb now that I've got the tools to do the job. I'm sure the summary of what I've been doing on this machine will appear for you to see as well. Because I know that some of you guys are interested in this, but if you're really interested in what's going on the Thinklacer channel, you can go to their video channel and you can see all my videos there, which are less exploratory and more demonstration, and if I say training, I'm very careful about training, because training implies that I'm an expert and that I know what I'm doing. I know a little bit about what I'm doing, but I'm certainly still no expert. Well, I shall see you next time, and I'm off to solve this 38mm lens problem. Bye for now.